Object-oriented programming is the dominant paradigm for organizing programs used today when developing large pieces of software. It has had a huge influence on the design of programming languages, including Python and many others, and it builds on the ideas of data abstraction and mutation that we've talked about already. So here's the story. We need to organize large programs that are very complex into small modular components that can individually be written and tested and thought about all at once, because humans can only think about so much complexity at a time. We do this with data abstraction, but object-oriented programming takes that idea one step further by bundling together multiple pieces of information, like with data abstraction, and also related behavior, so that an object, which represents something in the world, such as a date, not only stores all the information necessary to represent that date, but also can perform date-like things, such as determining what day of the week that date falls on. The idea behind object-oriented programming is that you think about your program and all of the computation that it performs not as one long list of information and then functions operating on that list, but instead a bunch of different objects that interact with each other, where each object keeps track of its own information. So each object has its own local state, which may change over time. So mutation is often involved in object-oriented programming, although that's not necessary. But when mutation happens, it doesn't happen in some global list that keeps track of all the information in the program. Instead, the information that's changing belongs to a particular object. Each object should know how to manage its local state, meaning that it keeps track of what changes are allowed, and the way in which you interact with an object is using what's called a method, which is a function that's particular to that kind of object. Several objects may all be instances of a common class, which is a type of object, so you can have many different lists that all behave the same, and different classes may relate to each other. Built into Python and many other programming languages are specialized syntax and vocabulary to support this metaphor. A class defines how objects of a particular type behave. An object is an instance of a class, meaning that each object has a type, which is its class. And when an object is created, it has that class for all time. And then there's this concept of a method. A method is a function called on an object using a dot expression, such as if I have a list S, I can write s.append5. Append is the method. It's invoked on the list S with the argument 5, and that puts 5 into the list S. And what makes methods different from functions is that a function is typically defined in the global frame, and it can be called on any value, whereas a method is specific to a particular object. So I can't just call append on anything, but I can invoke it on S because S knows how to append. Let's look at a built-in class, the list class. In fact, we've been calling list like it's a function, but it is a class instead. And calling list on an iterable creates a new list object. This is true in general in Python, that if you have a class and you call it like it's a function, then you're creating a new instance of that class. So an instance of a list is a list. In this case, a list containing 0, 1, and 2. If I ask what the type of S is, I see that it's the list class, the same result that I would have seen if I had just typed list. And it's not the list itself, but its class that describes all of the possible behavior related to lists. The list class defines how everything about how lists work, such as the methods, how addition and multiplication work on lists, and how item assignment and lookup work on lists. So it's up to the list class to know that the element at the beginning is element 0 instead of element 1.